this topic is easy but at the same time challenging because and tedious. Yeah, because more often than not you'll be dealing with fractions, and with fractions things will go haywire. Yep. Okay. So but don't worry, this one we'll see what to do, and then after this tutorial, I think you have a broad idea on how to tackle different things already, because we have different issues in this topic. Okay, can all right. So in this one over here, we have our sequences and series. Okay, first one. Okay, first one, right? What I want you to realize is something like that. Okay, so we are expressing each of the following series as the sum of its terms. Okay, for this chapter, I also won't ask you to like, for the person who uploaded question 4, thank you so much. Yeah, I I will I will yeah, but that's question 4 lah. But the rest, I don't see anyone upload yet, but it's okay. I will save that for differential equation. Okay, so differential equation onwards, I will start to want to see how you do. And P and C also, I want to see how you do. Okay, but for this one, I think since a lot of us are not here, I'll just quickly skim through my own lah. Okay, all right. Question 1. Express each of the following series as the sum of its terms. Okay, I realize I haven't give out some of yours yet. Yes. Huh. Okay, so right, the thing is, Arish, Sophia here, Sophia, okay, Sophia Cyrus, okay, thank you. Okay, so right, from other classes also, I noticed that misunderstand lah, because this question asks us to express as the sum of its terms. I see people that evaluate the final amount, which you are not required to do yet. Okay, but for this question, very straightforward. It's an exercise for you to write out the individual terms. Okay, to roughly see how it works and to know what does this mean. So you are adding 1 over r factorial from 1 to 5. So means you have 1, 2, 3, 4, 5 terms. The r changes. You roll the r from 1 up to 5. Okay, can So in the same way also, the second one over here, we have sum of this thing and then 2 power r plus 1. Okay, you're adding from 0 to 5. So when r equals to 0, here r power 0, negative 1 power 0, 2 and power 2 power 1, 0 plus 1. If when r equals to 1, you raise this by 1, raise this by 1, right? When r equals to 2, raise by 1 again, raise by 1 again. So you're adding all the way until r equals to 5, and then you get something like that. Okay, Can? Now I want you to pay attention. I've mentioned this in the lecture summary thing if you were there. I mentioned about this particular component over here. This one over here is to include for alternating signs. So if your sequence has plus and minuses, right, we need to include this in. Okay, whether is it r or r plus 1, we test using the sequence itself. I'll tell you how to do it later. Okay, part C, right, same thing also. You can just sub r equals to n all the way until r equals to 2n. Then you get something like that. Now, for this particular question, right, I'm going to tell you something, because this one over here, right, used to be, you need to do something like this. You will end up with 1 over r plus 2 minus 1 over r, something like that. Okay? I think so lah. I think so. Right? Yeah. Then there is a way to, correct? There is a way to add everything up, and then you need to add up using this thing called the method of difference. Okay? Means that you're going to add, and then you're going to cancel somewhere down the line. Okay? But the thing is that this one is out of syllabus. Okay? But nevertheless, right, I should also tell you what is it like lah. Okay? So this is out of syllabus. Okay, so don't worry too much about this. Okay, but I should also tell you like how does it look like. So it should look something like this. Sorry, okay. So let's say if you need to do method of difference, okay, you will get you need to split this to a over r plus b over r plus 2. Okay, so you have your a and b by doing the partial fraction, right? Now then you start substitute n into this, you get something like this. Substitute n plus 1, you substitute n plus 1. Substitute n plus 2, you get something like this. Substitute n plus 3, all the way until substitute 2n minus 1, substitute 2n. Okay, and you will start to see that actually, hey, this one and this one can cancel out. This and this will cancel out. By extension, the next one here and this one will cancel out. this next one and this will cancel out. So what you are left with just this part that didn't get cancelled out and this one that didn't get cancelled out. And you get a finite, a very nice thing over here. Okay, can so this is the so-called method of difference. So I'm just showing it to you. Now, if so happen this year, because this is taken out from syllabus, so if happen that this year that they forget to take out the syllabus and they want you to do, more often than not, which won't happen okay, but more often than not, you would need to do, they will give you the method to do, and then you need to just use whatever that they give you and just do it. Okay, and the thing is that, as so now the purpose of me telling you this is for exposure purposes lah. Okay, you need to be at the back of your head, just be aware that this thing exists, and then you need to use this to, and may not need to use most likely not need, you don't need to use, but you may need to use this in case it comes up. Okay, can just at the back of your mind kind of thing. So you don't have to pay too much attention for this, but just know that it exists and you may need to use this. Okay, can. So this was the previous one. Okay, so let's take a look at, okay, so this one really out syllabus. Okay, next. Okay, question 2. I'll quickly go through question 2 also. The exercise in question 2 is the reverse of question 1. Question 1, they give you the summation, they give you the general term, but you are required to write out each term. For this one, they are giving you the sum. Okay, they are giving you the terms. They want you to find in a compact general term with the sigma notation over here. Okay, so how do we do this? Okay, how do we do this over here? Okay, we have a few ways to do this. Okay, over here, observe, right, that this one is actually a arithmetic progression. Okay, right? So 1, 4, 7, 10, right? This is an arithmetic progression with common difference 3. Your general term would be a plus n minus 1 times z, correct? This is the formula, right? So this is your general term. Okay, so you can write part A, you can write it as, okay, you can write it as sum from R1 to 30 because you're looking for the first 30 terms. Okay, and then you have your 3n minus 2 like that. Okay, now or. The second way to do it is, okay, let's say if you itchy, you don't want to start with 1, you want to start with 0, right? Correct? So you start with 0, you count all the way until 29. You have 30 terms over here. Okay, if your limits change, your expression needs to change as well. Okay, and because of that, right, your expression needs to change to a 3n plus 1. Okay, something like that. Can Now I will push one step further. Let's say if you even more itchy hand and then you decide to do a bit more, right? Okay, instead of starting by 0 and 1, you want to start by 2. Also can. No one does this lah, but as in some questions may start with 2 lah, but yeah. So if you start with 2, right, you need to end with number 31. Okay, and this would be 3n minus 5. Okay, your sequence would be 3n minus 5. So technically speaking, the best way to represent would be from 1 to 30 lah. But technically the rest are not wrong, and then we can see how will these two appear in the later questions, especially question 6, 7, if I'm not wrong. Okay, all right, so this is the first one. Second one, okay, part B. Now we have two components over here. So this one, right, you can see that clearly this is an, yeah, factorial, right? So this one is a E-math number pattern kind of question, correct? So what is the number pattern? 3, 5, 7, right? So this would be, so this one is actually 2r plus 1, correct? If you can find out the general term 2r plus 1. Okay, otherwise, right, you just make use of the AP formula, the Tn will be equals to A plus n minus 1 D. D is 2, right? So this one will be 2n plus 1. Okay, something like that. So this will be 2r plus 1. Okay, then you need to multiply by 1, 2, 3 factorial, multiply by r factorial. This one a bit hard to start from the other numbers, but not impossible lah. Okay, but yeah, to play safe, I'll just start from 1 to 2n. Okay, so this will be for part B. Part C. Part C even more straightforward. Okay, on top would be sine r plus 1x. Below is actually tangent power r of x. Okay, r to 1 to the first n terms like that. Okay, r equals to 1 to n. Okay, so this one I'll just go through very quickly lah. But I think you can see the pattern. Can so this one can see the pattern immediately. Okay, now the next one is the one where I will do a bit more. Okay, this one straightforward. Okay, still need this or no need? Still need? Okay, for a while. Can I let you. Okay, can okay. So let's go on to question 3. I think question 3 I try here. Okay, sorry, I jump here and there. Okay, question 3. Now, over here, if a series is given by Sn equals to something like that, find the general term Tn. Okay, so this one we will need to make use of our formula. So the Tn, right, will be equals to Sn minus S of n minus 1. Okay, can see how this works? Can So over here, what is Sn? Making use of this formula over here. So we have a 1 minus 2 power n plus 1 divided by n plus 2 factorial. Okay, so this one minus of 1 minus 2. Okay, the previous term would be 2 power n over n plus 1 factorial, like that. Agree? Right, the previous term. Right, if not, you just substitute n minus 1 into this to reveal this. Okay, next, you can simplify this to something like 2 power n over n plus 1 factorial minus 2 to the power of n plus 1 over n plus 2 factorial. Okay, so now, right, I like up to you. I don't know what's the mark allocation like, to be honest. So let's say if it's just 1 mark, just let it be lah. Okay, let's say if you have 3 marks, what should you do? How do you simplify it to a common one singular fraction? You need a common denominator, correct? So now you need to understand what is this factorial notation. Okay, I'm not too sure whether was it explicit last time when you learned A math or something, or when you have this. Don't know whether you started your PNC or not. But okay, example I give you an example. 5 factorial is equals to 5 times 4 times 3 times 2 times 1. So this is what the factorial means. Correct amount of ways to arrange 5 distinct objects or 5 distinct things. Okay, now I'm going to make use of this. So this thing itself, right, I can compact this and write this as 4 factorial. Okay, so technically speaking, 4 factorial topping up a 5 will give you 5 factorial. Okay, so I'm going to use this trick to find my common denominator. Okay, so for this question over here, right, n plus 1 is smaller, n plus 2 is bigger, correct? So what should I do to top up this whole thing? I will need to top up with n plus 2 and the n plus 2 over here. Can Okay, so okay, I squeeze in lah. So next step, I will have something like 2n times n plus 2, okay, minus 2 power n, then I put a 2 over here. Does it work? Yes, it should work. Okay. This one divided by, okay, this one at the bottom, right? This one at the bottom will become n plus 2 factorial, just like how it works over here. Okay? Can understand what is it like? Can So at the bottom again, so your n plus 1 factorial time topping up with n plus 2, you will get n plus 2 factorial. So this top up, you get the next factorial. Can Okay, so with this, let me simplify this to 2n times n plus 2 of this minus 2 of this. Okay, all divided by n plus 2 factorial. So we can simplify this to n times 2 power n over n plus 2 factorial. Okay, so something like that. Okay, something to simplify to. Can Okay. Okay, so that's the trick for this question lah. Okay, first one is the concept of Tn. Second one is the factorial. Okay, questions at this point? Any questions? All good? Hey, it's in OneNote, don't worry. It's not loading. Oh, must be my line. Okay. Okay, okay. Uh, okay, let's look at part B. Express the following sums in sigma notation. So it means that we want to compact all these sums to a single general term. Okay. Now, if you are thinking of compacting them together, right, you need to think r equals to 1, r equals to 2, r equals to 3, correct? So which one rolls off, or what is the pattern like? Okay, so example 5, 10, 15. Obviously, this one is 5r, correct? R equals to 1, r equals to 2, r equals to 3. Okay, the next one to consider is, right, okay, there are many considerations. So if you were to hook on 1, 3, 5, right? R is 1, then you got r plus 1, r plus 2, right? If the next one is r equals to 2, right, but it's not 3, right? So it's a bit weird to hook on this one, okay? Even this one also is a bit hard to hook on as well, okay? So what I would encourage you to think of is you need to find, try your best to find some multiple of r. So the multiple of r is actually somewhere in the middle, okay? You can do that, or the other way to do is to consider 1 to 3, 3 to 5, right? So this is actually 1 plus 2r, okay? Then 3 plus 5, 5 to 7, this is actually 3 plus, sorry, 2 plus 2r, 3 plus 2r. Okay, something like that, something like that. Okay, so anyway, you can consider this sequence like that, but I will hook on the 5 and the 2. Okay, the multiple of 5 and the multiple of 2. Okay, so if I want to do that, right, now I cannot write. Wait. Why I cannot write? Okay, so now what I need to do is, okay, B part 1, right? Okay, so this one over here, I will express as sum from r to 1 to infinity. Okay, sum to infinite terms. On top over here is 5r. Okay, below over here, right, I will put a 2r. Okay, so this one is the term in the middle. Now the one on the left wing, right, is actually 2r minus 1. The one on the right, it will be 2r plus 1. Okay, can so it's to hook on 5r and 2r. Then the 2r will give you your 2r minus 1 and 2r plus 1. Okay, so it will give you these and these. Okay, very nice. Can. Next one, part 2, B part 2. Okay, so same thing, we are going to sum, right, from r equals to 1 to the first n plus 1 terms. Okay, now this one, 1, 3, 5, 7, 9. This one is an AP over here, right? So the general term over here would be a plus n minus 1 times the common difference. You will get your 2n minus 1. Okay, so over here I have 1 over 2n minus 1 square. So this, sorry, 1 over 2r minus 1 square. Okay, can Okay, so far like that first. Now you can see why I need to start to leave a gap, right? Okay, because notice that we have minus, plus, minus, plus, minus, correct? Alternating signs, right? So means we will need to include this particular factor of -1 to the power of something. Whether is it r or r plus 1, I don't know yet. Let's try. When r equals to 1, the first term over here is -1, correct? So when r equals to 1, it is indeed negative. Okay? Now, then if r equals to 2, -1 square will give you a positive 1 over here. Okay? So like that, we test like that. What if they swap? It will be plus, minus, right? Then if r equals to 1, you will need r plus 1 to make the first term positive. Can you understand where I'm coming from? Okay, so this will be part 2. Okay, so this one over here, we test and run. okay, and see whether do we need to put the +1 or -1 or just leave it as R. Okay? Okay, questions. Okay, so this one I put here, this one check. Okay, something like that. To see whether is it an R or R plus 1. Okay, so that's for question 3. Okay, question 4. Okay, question 4. Can I get a show of hands who used GC to do this? Oh, okay. Cyrus used GC. Anyone else use GC? Okay, Giselle also use GC. Okay, so Giselle, how do you use GC to do this? Like what feature in GC did you use to get the first few values for question 4? Part A, correct. Put inside and press table. Okay, then for Cyrus, is it the same?
I did this on a whim, so basically I just plugged it in and see what I just plugged it into the actual thing and
Plug it in and see what it goes. Okay, can.
on the GC.
Okay, but you just substituted the values in.
Yeah, but it's on the GC.
It's on the GC. Okay, so I would recommend. Okay, yes, correct. So I would definitely recommend Giselle's method. Okay, let me load this GC thingy. Let me show you how does it work on GC. Okay, or how would I would do it on GC. Yeah. Yo, why is it so slow? Oh, it's not loading. I reloaded.
Oh my god.
Right, the table works, right? Yeah, we have a sequence mode. That's precisely it. So yeah. Okay, let's see. Okay, now for question 4, I'll be just showing this. I won't write it inside there. I'll just show you what I do. Okay, so using the GC, right? Okay, so let's do this. Now what I will need to do is I'll go to Y. Do you need sequence mode or not? I say no need lah. No need sequence mode lah. Okay, I can just let it be. But if you press graph, then there'll be a very weird graph coming out. But sequence mode will allow you to see the dots, yeah, in the graph mode. Okay, but nevertheless, because we are only concerned about the values, so let's take a look. Here, so I will just need to put in a -1 power variable divided by variable plus 1 variable plus 2. Okay, now next I will do second. Okay, key in this expression, right? I put second. You see the F2 over there, the window, F2 window. I press on that button. Okay, they will ask me where do I need to start my table and every step of the table. Okay, once I set that in already, second graph, then I get table. So you get your first 3 values, which is -1/6, 1/12, -1/20. Okay, so this 1, 2, 3, right? Okay, next, how to find U20? How to find the 20th term? Scroll down lah, go all the way to 20 lor, like that lor. Okay, yeah, 1/462. Okay, just go down. Can All right, so mainly just like that. Okay, now let's say if they ask for starting with 100, if they ask for U120, what should you do? This one, don't bother scrolling down because it's going to take forever. You go to second table set, table start at 120, right? Then you just straight away go back to the table. Then there you have it. Okay, it's very small, like extremely small. Okay, what does this mean? 6.8 e -5, right? 6.8 times 10 to the power -5. Okay, this e, right, means is times 10 to the power -5. So it means this is 0.000068. Okay, this one over here 0.00007. Okay, can so the e means 10 to the power of. Okay, yeah, I have yet to figure out the recursion. I need help with that. So yeah. Okay, next for part B, find the sum of the first 10 terms of the sequence. Unfortunately, in table mode or in the graph mode, we cannot sum the terms of a sequence, right? But we can go back. So let's go and quit second quick, go back to the main page over here. Let's key in the expression, but we can make use of alpha F2 summation. Okay, do you see number 2 summation? Can, huh? Summation. So I will add from variable from 1, variable from 1 to 10 lor. Look for 10 terms, right? Then I key in the expression lor. So A okay, enter. Then negative 0.110. You don't have to key in one by one. So you just use the summation tool. Okay, next one. Okay, I will have to go up. Okay, I press enter to copy. Find U5 to 20, right? So I just need to find the 5. Where's my 5? My 5 is down there, 20 and 5. Change law, then enter law, you get another value. Okay. Now, this one very happening, very easy, very happy, right? Okay, but I'm here to tell you, in A levels, right? Are they going to ask you this kind of question? Obviously, no lah. Okay, because you are A level students, advanced level. This one very beginner lah. Okay, so what we need to do instead, right, is that we will be dealing with unknowns. Okay, more often than not, we'll be dealing with unknowns. Okay, so the algebra part is the headache lah for us. Okay, but nevertheless, we have cool tools like if we need to evaluate, then we can use this to double check. Okay, can now. All right. So with this, I will go to question 5. Okay. Okay, question 5. Question 5. Okay, haven't do all. Okay, never mind. Today I do. Okay, so question 5. Now, without using your GC, okay, find the limits of this sequence over here. Okay, now, if you want to use your GC, right, can is can. Okay, let me quickly, okay, let me just do the first one, then I show you for part B. Okay, so A. Now, I will present two different kinds of notation. Okay, so that up to you lah, which one you want to use. Okay, now the first kind of notation is just the arrow notation. Okay, so as r goes to infinity, so I will write as r goes to infinity, what happens to this sequence? What happens to this expression? Okay, yeah, so your ur will be equals to 1, okay, or maybe 1 over 2r plus 1. Now the denominator becomes infinity, right? Correct? So 1 over very big will become very small, close to 0. Okay? And because of that, your ur will be approaching 0. Okay? Something like that. So it's part A. Now the other notation that I would like to present, right, is the limit notation. Okay? So you can write it like this. So limit as r goes to infinity of 1 over 2r plus 1, like that. Okay, you can also express it like that. Okay, so this one will be just equals to 0 directly because it will become very big lah. Okay, 1 over big. Yep, direct substitution. Okay, now part B. Part B is the one where we need a little bit of algebra. Now, part B, as r approaches infinity. Okay, here, when you more or less substitute in your infinity, right, you will get infinity over infinity, which doesn't give you any information. Okay, so instead, okay, so because it doesn't give you any information, we call this indeterminate. Okay, we cannot determine anything from here. So instead, right, we will need to do some algebraic adjustments. So I will need my ur to be 5r minus 2 over 3r minus plus 1, right? The technique that they covered in lecture is to divide by the highest power of the term. Okay, so this would be 5 minus 2 over r over 3 plus 1 over r. Okay, so as r goes to infinity, oh sorry, this one I put here. Okay, so as r goes to infinity, the ur would approach 5. Okay, over here, as this goes to infinity, right, 2 over big will become 0. So 5 minus 0 divided by 3 plus 0. So this will be equals to 5 over 3. Okay. Now, the second notation would be like this. Limit as r goes to infinity of this. Okay. So this one will be equals to limit as r goes to infinity of, we do the same working. Yes. My bad. Okay. So here I will have 5 and 3. Okay. Minus 0. No. Plus 0. So I will get my 5 over 3. Okay. Something like that. Can ah? Can? Okay. Now, let's look at how does it look like in the graph. Okay. How does it look like in the graph? So yes, what I'll do is I'll probably go to mode, change it to sequence so that I can see the graph on how it looks like. Okay, go to sequence. Okay, then I press the Y. I'll put in 5 variable minus 2, 3 variable plus 1. Okay, now you can check the table. Oh, 120. Oops. Okay, change the table start to 1. Okay, like that. Okay, you can slowly see that it really goes to a certain number lah. Okay, you can see that it goes to a certain number. At the same time, right, if you look at the graph, yeah, so it tapers off and converges somewhere along this line lah. Okay, can you see something like this line over here? Can you see my browser? So it will converge along this line over here. Okay, it will plateau off somewhere here. Actually, I haven't tried. Actually, can, right? Can, right? It still presents itself as dots, right? No, this won't be dots. This will be the curve. Yeah, actually, yeah, that's also true. That's also true. Yeah. Okay. Yeah, so technically, if you have a curved line that you plot from your graph, right, you can also see that it tends somewhere lah. Okay. Yeah. Yeah. No, and then like the fact that it tapers off like that, right, doesn't really mean anything because a lot of functions also taper off like that, but they go to infinity. For example, square roots and ln. Okay, the graph will maybe like that, but it's actually increasing very slowly to infinity. Whereas for this one is this one will be very much closer to 5 over 3. Okay, can so sometimes GC plays tricks on our eyes, or maybe it couldn't be represented enough because the growth is too slow. Okay, now let's look at the third one. So same technique, UR will be equals to R square minus 2R over 3R square plus 4. So same thing, you can divide by the highest power of the polynomial here. So you will get your 1 minus 2 over R and then 3 plus 4 over R square. Okay, so as R goes to infinity, your UR goes to 1 and 3 minus 0 plus 0. So this will be 1 over 3. Okay, can now once again, right, there's many ways to find out the convergence of a sequence. Okay, so this one, right, the subtopic of this thing, right, is what we call the, okay, sorry, I go up a bit. This one is what we call a convergence or limit of a sequence. Okay, it is a convergence of a sequence. Can to see whether a sequence converges to a certain values or not. So this is not really much about adding the terms or finding the individual terms. This one is more like to analyze the behavior of the sequence. Okay, analyze behavior of a sequence. Can Yes, correct. So there is a convergence of a sequence, there is a convergence of a series, there's convergence of the whole function itself. Yeah, so it depends on what are you looking out for. Okay, for this particular case, we are mainly talking about the sequence converging. At one of the later questions, right, we talk about the series converging. They are different things altogether. Okay, and the techniques we do to analyze are also different. Okay, So the sequence, we look at algebraic methods like this. We look at whether is it AP or GP to decide whether is it converging or diverging. Okay, and if it's GP, right, what is the ratio such that it will get the final term? Okay, can so this would be question 5. Okay, now let's enter question 6. Now let's enter the real meat of the question. Okay, question 6. Now question 6, I will put a star over here because this is the basic idea of the sigma notation. Okay, so this one is to evaluate. Okay, the skill or the concept here is to evaluate sums or evaluate the sigma notation. Okay, can all right. So in order to evaluate sums, right, in general, I have two approaches for you. Okay, the first approach would be to observe and find the pattern. Okay, observe the pattern and see whether is it AP or GP. Okay, the second method would be to split your summation. Okay, can and for question A, right, I'll do both. Question B, you realize that we can only do one. Yeah, okay, can. So let's take a look at this. Okay, let's take a look at this. Okay, so part A. Now we are going to add from 0 to n minus 1 of 2n plus 1 minus 2r. Okay, now then this will be the kind of questions that we'll be dealing with in A levels also. Okay, now you see in this question over here, you need to be very clear on what is a variable, what is a constant. Okay, so in this expression, what is our variable, n or r? R is the variable, R is the term, or sorry, R is the thing that changes. Okay, whereas n is a fixed number that we are going to end off at, or in this case, this is just a constant number. Okay, n will change at different times, but the thing that is actually changing, right, is actually R. N is actually something that we set at the beginning or at the end, kind of thing. Okay, but the one that we keep rolling and adding, right, is actually R. So R is our variable. Okay, so take note of that. So now let's take a look. Let's analyze the pattern and see what is going on. So first method. No, no. Okay, okay. Okay, method 1. Okay, so this will be, okay, I want you to see something. Okay, so when r equals to 0, okay, this one, when r equals to 0, right, what term are you getting? Okay, you substitute 0 into here, right? Especially into r, you will get 2n plus 1, agree? Right? When r is equals to 1, what do you get? 2n minus 1, right? When r is equals to 2, you will get 2n minus 3. When r is equals to 3, you get 2n minus 5, and so on and so forth. Okay, let's look at the last one. When r is equals to n minus 1, you will get 2n plus 1 minus 2 of n minus 1, something like that, right? Correct? Okay, so that one I'll leave the calculation later, but this is how we do it. Okay, now then we observe the pattern, right? What pattern? Is there a consistent pattern? Have, right? You notice that over here, between here to here, right, there is a common difference of -2. Agree? So this one is an arithmetic progression, an AP. Okay, so here, because of this, we observe that this is an AP. Okay, and because of that, right, we can actually make use of the sum of AP. Okay, sum of arithmetic progression. Your SN would be equals to number of terms divided by 2, first term plus last term. Okay, okay, we can make use of this. Now, before we continue on, we also need to crack how many terms do we have. Okay, so how many terms are? Okay, so number of terms. Okay, remember how we do it during the summary? It just flew by. Okay, n terms, n minus 1 terms, n terms. Okay, how do you know it's n terms? Maybe Ananya, you want to try? Upper limit plus 1. Sorry, both the limits plus 1. Then you have lower limit plus 1. Oh, yes. Okay, so upper limit minus the lower limit plus 1, right? So the upper limit would be n minus 1 plus minus away the lower limit plus back the 1. So this will be just n terms. Okay, nice. This is nice. Okay, the other way you can think about it is normally 1 you count to n. This is just 0 to n minus 1, one step down. So it's still n terms. Yeah, that's the other way that you can see. Okay, so like that. Okay, so now what do we do? Okay, let's make use of this one, sum of an arithmetic progression. So we have n terms divided by 2. Now what is the first term? The first term is 2n plus 1. The last term is here, this ungodly one. So sorry, mine plus. Okay, 2n plus 1 minus 2 times n minus 1. So this is the last term. Okay, so with all this, right, you can simplify to 2n plus 4, and this will be n plus 2. Okay, can so this is observing that it's an arithmetic progression, and then we add from there. Can so this one I will spare the details. Okay, okay, now I'm going to show you method 2. Okay, in case you are okay, method 2. This one over here would be to split or expand the summation. Okay, can. So how do we split this up? Okay, so I will sum from 0 to n minus 1 of this whole chunk. Okay, so I can split this up. So constant multiples I can put in front. So technically speaking, I'm adding, okay, sorry, I will just do this lah. So n minus 1, I will sum 2n, okay, plus sum of from 0 to n minus 1 of 1 minus 2 times of this. Okay. Yeah, actually we can, but yeah, I'm just overthinking a bit and letting, yeah, technically you can do that. Yeah, you can. It's much better and more compact. Yeah. Okay, but I'm just showing the extra bits. Okay, so what do we do over here? Okay, first, is this a constant or variable? Constant term, right? And we're adding this constant how many times? From 0 until n minus 1, correct? So we're adding this n times, right? So this will be n times, okay, n times of, okay, n times 2n, okay? Plus the same way, I'm adding 1 n times. So this will be just n times 1. Okay, so technically I can combine them together lah. They are all constants anyway, right? So I don't have to split these two actually. You can combine them together. I'm just showing you like that lah. Okay, next, minus 2. Now here, right, there are many ways to do this. Okay, if you want to use the identity, okay, or if you happen to memorize sum from 1 to n of this is half r plus 1. Sorry, half n plus 1. Okay, half n plus 1. Okay, but the caveat is that we are starting from 1. Here, this sum over here starts from 0, right? So, okay, so this will minus 1, this will become n minus 1, but here will not change as, yeah, it actually does change to n minus 1. Yeah, yeah, your upper limit changes, but the 0 term is ignored. So, yeah. Yeah, actually you can. Okay, actually you can. Okay, but instead of thinking too much about transformation over here, right, I will just ask you to see what is this law. This is just adding 0, 1, 2, 3, 4, 5, right, and so on, right, correct? So you just make use of AP. This is still making use of AP. So what is the formula? I have n terms over 2. First term is 0, last term is n minus 1. Like that. Yeah, it's the same thing. It's the same thing in a different form. Okay. Now, even if you adjust this, like what Cyrus said, even if you adjust this down to 0 and n minus 1, you just sub in. Technically, you can't do, okay, officially you can't do that, but because you're adding a 0 term, and 0 is just 0, just nice, this is 0. So it's just subbing in from 1 to n minus 1 plus the 0 outside. But that one, yeah, correct, correct. Okay, but that one I'll just leave it for another question. But for this question, I'll just keep it as simple as this. Okay, can Okay, then you can tidy up to 2n squared plus n minus n minus 1. 2n squared plus n minus n squared plus n. So this would be n squared plus 2n. Then you can factorize and make it like the previous one. Okay, so two different ways to do. Okay, so obviously for this particular question, which one is easier? 1 or 2? 2 is easier? Wow, hey, Wei 2 is easier? Really, really, yeah. I'm glad you said that also, but yeah, yeah, correct. So exactly what Cyrus said, like, it's like, okay, easier to see, faster to do. Yeah, but I think, okay, for A level maths, right, I always prioritize on speed lah. Yeah, so definitely, if possible, do one, if possible. Okay, if possible. We're going to look at an example where it is impossible to do one. The next one, okay? Right, if you observe, right, is r squared and 3 power negative r, correct? When you sub in the terms 0, 1, and 2, and r equals 0, 1, 2, 3, right? You realize that it's actually not an AP. Okay, it grows in different direction. So there's no observable pattern from here directly. We have to split first. Okay, so what we need to do for this second question over here for part B. Okay, summing from n plus 1 to 2n of r squared plus 3 to the power negative r. Okay, we have to split them up. Okay, something like that. You have to split them up. Okay, now if we split them up, right, now over here, potentially we can make use of the given identity for this. Okay, but what is the problem again? You double check. The one given to us, right, starts from 0, but here we start with n plus 1. Right, here we are starting with n plus 1. R equals to n plus 1. Okay, so in order to make use of that, I will need to do some sort of editing. Okay, so this one over here is sum from n plus 1 to 2n, correct? If I want to split them up, right, it's actually sum of n plus 1, sorry, sum of 2n, which is the bigger number, minus of sum of, okay, 2n minus n plus 1 plus 1. Top minus bottom plus 1. Or straight away, you can see that actually, if you are looking for n plus 1, right, what is one number before n plus 1 is actually Sn. Okay, the n. Okay, can so either way. Can so because of this, I can write this as, okay, sum from 1 to 2n of this minus of sum from 1 to n of this r squared. Can? So it is exactly like how you do in your AP GP. Okay? Can so this is the first component. Okay, second component. 3 to the power of negative r. Now, okay, r square, right? By right, you're supposed to visualize and find that it's not AP, neither G, not AP, not GP. Okay, so this one they have given you the identity to evaluate. Over here, is it an AP or GP? GP, right? So how is it GP? Let's test. Okay, so this one over here, I'm going to write the terms out. So the first term would be 1 over 3 to the power n plus 1. Okay, this one, right, is actually 1 over 3 power r. Okay, so I sub in n plus 1. Okay, sub in the next one n plus 2. Sub in the next one n plus 3. And so on and so forth until I have 3 power 2n, like that. Okay, can so this one over here, right, what is the, okay, what is the, is there any common difference or common ratio? There is, right? The common ratio is 1/3. Can see? Can see? 1 over 3n, 1 over 3, correct? 1 over 3n, 1 over 3, 1 over 3. Can see? 1 over 3 square, right? Can 1 over 3n, then you get 1, 2, 3 of this. So every time you, the next term, right, you just multiply by another 1/3. Can see? So this one over here is a geometric progression. Okay, now so this is a GP like that. Okay, and then how many terms do we have? What is the number of terms? So we have n terms. Okay, you can do the same math and then you can arrive at n terms. Okay, can now with this, right, because this is a GP, right, the Sn would be equals to a 1 minus r power n divided by 1 minus r, something like that. Okay, so let's take a look at how do we apply. Okay, so first one, I'm going to apply the results. Yeah, so this is a lot. So I will apply the given results over here by substituting 2n and n respectively. So here I got 2n over 6, 2n plus 1, 4n plus 1. Okay, next one, minus of, okay, this one is n. So I just copy and paste the expression. No space, so I do that. Okay, last one. This one over here, I make use of the Sn formula. First term is 1 over 3 power n plus 1. First term. This is the first term. Okay, so this over here is the A, right? And then 1 minus ratio to the power of n terms. This one, be careful. This n is not just power n, but n terms. How many terms? Okay, divided by, okay, this one over here, number of terms. Be careful. Okay, next one, 1 minus r, like that. Okay, let's take a look at how to factorize things out. Technically speaking, if you see very slowly, okay, if you can see very slowly, okay, I can take out n, I can take out a 6, right? There's an n over 6. There's a common 2n plus 1 as well. Okay, so I will factorize that out and try to make it nicer. So n over 6, 2n plus 1. Over here, I will have a 8n square. Sorry, not 8n square, just 8n. 8n plus 1 minus n minus 1, or minus n plus 1, like that. Okay, now this one over here, right, I will have 1 over 3 to the power of n plus 1 multiplied by 2 over 3, sorry, 3 over 2 from the denominator. Okay, and 1 minus 1 over 3 power n. Okay, the 3 over 2 is from the denominator, and I can cancel these two things. Okay, so altogether, I can simplify this to n over 6, 2n plus 1, 7n plus 1, plus 1 over 2 times 3 power n times 1 minus. So this one cannot simplify, so this one I will let it be. Okay, and that's my simplest expression already. Okay, can now, so this question, right, is it difficult? I won't say that it is too difficult, but the because the concept is things that you've already known from previous chapters. Okay, so technically it is not as difficult as you think, but the problem lies in the fact that you need to borrow a lot of concepts from the different chapter. For example, you will need this concept to split the summation. You need the concept to find s of n plus 1 to s to n. Okay, you will need to adjust some algebra skills over here and factorize nicely. You need to recognize that this is a GP, and you need to put that you need to make use of the sum of a GP. So it's really a lot of things going on here. Even though the question seems simple, the concept is easy, but it relies on a lot of previous knowledge. Plus the fact that you have fraction, right, makes it even more not friendly. Okay, so but I'm here to tell you, don't worry too much. Okay, you are seeing this for the first few times, so things will be better once you get more exposure and practice. Can so the nature of this chapter, right, is not difficult, but it relies on a lot of previous concepts. Okay, so the thing is that I don't want you to give up. This one is something that you can do. Okay, don't stare at this and like, wow, what, this is crazy, something like that. It's just the structure. Okay, it's just the structure. It's just the nitty-gritty math stuff. But the idea, okay, think of the big idea about this question. Okay, the idea is that it's just summation and making use APGP repeatedly and so on. Okay, so don't be too worried about this, and practice, must practice. And one last thing also, you need to have a keen eye on the detail. Okay, example, sum from where to where, how many terms are all these details you must be alert, okay, and observant. Okay, and one more use of such detail, right? Let's push on to the next question 7, our last question of the day. Okay, let's push on to 7. Question 7. All right, question 7 over here. Okay, technically speaking, now I've seen working where people expand because they already give this identity, given that this equals to and so on, right? So I see people expanding this and trying to get your R3 plus R in front and some remnants behind. It's not wrong, but there is a much leaner way to do this. Correct, change the bounds, do some transformation. Okay, so over here, right, I want you to observe. Okay, first one, part 1. Now, you are summing from R equals to 10 to 2n of R times 3 plus R. Okay, so what do you do over here? Compare the form. Okay, R3 plus R matches with the R3 plus R in the question. The form is the same, means that I can potentially use this identity. But the one given in the question starts from 1, we are starting from 10. So it means that I will need to express it from 1 onwards. So this will be sum from 10 to 2n, means that this will be sum of 2n minus sum to which term? 9, 1 before the 10. Okay? Minus the 1 before, so that you can include the 10. Okay? So what is going on over here? Express this as sum from 1 to 2n of this thing minus sum from 1 to 9 of this thing. Okay? This one also put a star over here. This one, yeah, rather important. Okay? Okay. What do we do? Apply the formula. So 1 over 3, substitute. Then you sub in 2n again, plus 1. 5 plus, sub in 2n. Okay, can? So if once you get it to R from 1 to 2n, right, then you can apply this directly, substitute in with your 2n over here. Okay, next one, same, I can start from 1 to 9, so I need to substitute in the 9. Okay, so this one will be minus 1/3 times 9 times 9 plus 1 times 5 plus 9, like that. Yeah, that one, yeah, nothing's technically, yeah, that one is okay. You can use GC. Yeah, you should use GC to check. Okay, So over here, you have your 2n over 3, 2n plus 1, 2n plus 5, minus 420. Yeah, all the more you should use your GC to check for the correctness of this thing. Okay? Yeah, GC saves time as well. So time is gold. Yep. Okay, question 2. Okay, question 2. Let's observe over here. We have r plus 1, r plus 4. Okay, r plus 1, r plus 4. But you observe the former. This, right, r plus 1, r plus 4 is actually comparable to r and r plus 3. It's just one off, correct? So the question is, okay, I will write this first. Okay, so the question is, how do you change from here to r? And how do you change from r plus 4 to 3 plus r? I will need to replace r with what to do that? Okay, what do I need to replace my r such that I can change this to r and change this to 3 plus r or r plus 3? R minus 1, 1 or r plus 1? Minus 1. So replace this with r minus 1 to change. Okay, so let me erase this. So when I want to change the expression, right, I also need to change the limits, correct? So when r minus 1 equals to 1, it just replace r equals to 2. Okay, on top over here, r minus 1 equals to n. So r will be equals to n plus 1. So change the limits like that. Okay, now then we change the expression one shot. Okay, so this one would be change from r to 2 to n plus 1. Here we change r minus 1 plus 1. Okay, change again r minus 1 plus 4. Okay, so now the final one, this final line, right, fits the form over here already. You have your r plus 3, r times r plus 3. Okay, then the problem now is that you don't start with 1, correct? You're starting with 2 instead. So what should you do? This is S2 to n plus 1. So means how do I split this up? This would be Sn plus 1 minus of S1. Correct? Agree? Right? But S1 at the same time, right, is also the first term, technically speaking. Yeah, which is, yeah, T1 or first term for this question. Okay, so I'll be making use of this to form the next line. Okay, so here I will get my sum from 1 to n minus 1, r plus 3, okay, minus of the first term. Okay, so when r equals to 1, so I have 1 times 1 plus 3, so 4. Okay, okay, I'll just write more to add detail, but yes, please write 4. Just write 4, but I'm explaining that. That's why. I know. Yeah, I'm long-winded that way. Okay, but cannot see lah. Some people, yeah, yes, correct. In future exercise, I'll just 4. Okay, I'll 420 and 4 directly. Yes, but yes. For now, I'll make it very clear. Okay, next one. Let's make use of the formula. So I have my okay. So 1/3 over here. N plus 1. And technically, you can jump there, lah. You can, but I'll do it slowly, okay? N plus 1 plus 1. Then 5 plus n plus 1. Yes. Okay, minus 4. So I have something like 1/3 n plus 1, n plus 2, n plus 6, minus 4. Okay? Can, Wait, 3/3 what?
But it would be even funnier if like originally I treat plus one as like one variable, then I get 8, then I would get the
Oh,
same thing.
oh, oh. That's funny. Okay. Can. Okay. Let's move on to the next one, part 3. Okay, part 3, right? Same, same. Same, same. Now we sum from 1 to 2n of this. Okay, same consideration. Okay, now the one given in the question again is r times r plus 3. The one that we have here is r minus 1, r plus 2, right? So what do I need to replace such that I can get from here to here and from r plus 2 to r plus 3? Replace r with r plus 1. Okay, so it's the reverse of the previous question. Okay, replace r with r plus 1. So over here, I will have just replace the limits. R plus 1 equals to 1, r equals to 0. R plus 1 is 2n, r would be 2n minus 1. Okay, so here are my change of limits. So from r0 to 2n minus 1. Okay, okay, r plus 1, r plus 1, minus 1 and plus 2. So I have, yeah, the one below over here. Yes. Okay. Can all right. So over here it starts from 0, but once again the question gives us starting from 1. R equals to 1, correct? So what do I need to do would be to have this starting from 1. Yes, I will make the imagination come alive. Yes. Okay, plus. Okay, so this is the term when R equals to 0. Okay, so when r equals to 0, this will be 0 times 3. Yes, which is also 0. Okay, can So here, right, we are starting with 0, right? So I will break off the 0 behind and I will start from 1 over here. Previously, I will need to take this one because I'm starting from 2. So in order to start from 1, I need to minus back. For this case over here, because I'm starting from 1, I'll just need to evaluate what is the 0th term behind, okay, which is also 0. So, okay, for this question. So be careful, the detailing of this question. Okay, so this will be equals to sub in 1/3. Okay, 2n minus 1, sub in 2n minus 1 plus 1, and 5 plus 2n minus 1. Okay, and all together we have 2n over 3, 2n minus 1, 2n plus 4. Okay, if you want to simplify it even more, okay, like that. Okay, can Okay, so once more, the emphasis is we need to check the form, check and match form in question, okay, in the given part of the question. Okay, next thing to do is when you change your limits, you also need to change your expression at the same time. So it's like integration by substitution. Okay, change limit, change expression, change your derivative, your differential. Yeah, okay. Okay, I think this is a good place to stop. Okay, then we'll continue with we'll continue with 8 and the other questions in the next, in our lesson on Friday morning. I'll come in for chemistry. Okay, and I think Friday I won't record. Friday, since everyone is back, right, I'll just do the board work thing all over again. Can okay. So yeah, so you are the lucky class who I only just need to record this one lah. Then the fellow CAs don't miss much. Yeah, they only miss this. Okay, can. Okay, so that's all for today. Any burning questions? Anything to ask? Okay, can so don't give up. Okay, Okay. One more thing is also, let me label this for you also. This one is to transform expression and limit. Okay, in case you want to find out what's the skill. Okay, to transform the expression and the limit. Okay, so that's all. Okay, thank you, thank you. Okay, you have your break now until picnic, right? Is it? Is it picnic after this, or still have lesson? No more lesson, right? Yeah. Oh, you have trials. Okay.